Hello everyone, today we will be discussing trigonometric identities. In particular, we will be deciding whether or not some expressions are from identities, we're asking to verify them, and we'll also be simplifying expressions. Now let's recall some identities that we met very early on in this section. Reciprocal identities are identities where a trig function is the reciprocal of the other. For example, cosecant of x is 1 over sine x. Secant x is 1 over cosine of x. Cotan of x is 1 over tan x. Similarly, sine of x will be 1 over cosecant of x. Cosine of x is equal to 1 over secant of x. And tan of x is 1 over cotangent of x. The quotient identities. Tan of x is equal to sine of x over cosine of x. Cotan of x is equal to cosine of x over sine of x. Let's recall the Pythagorean identities, where sine squared x plus cosine squared x equals 1, and tan squared x plus 1 is equal to secant squared x, and 1 plus cotan squared x is equal to cosecant squared of x. Then there are even and odd identities, and these are from our ideas of even and odd functions, where we know that sine was an odd function, so sine of negative x is equal to negative the sine of x. Likewise with cosecant of negative x is equal to negative cosecant of x. Tangent function is also an odd function, so tan of negative x is equal to negative tan of x, and the cotan of negative x is equal to negative cotan of x. The cosine function is an even function, so the cosine of negative x is equal to the cosine of x, and the secant of negative x is equal to secant of x. Let's talk about some useful things that we need to do to be able to simplify an expression. In simplifying expressions, the objective is to use identities to write one trig function in terms of another, such that some terms will eventually cancel out. Usually we end up with one trig function in the final form. There are a few things that you may have known before coming to this class. If you didn't know them before coming to this class, you will learn them right now. First thing is about finding common denominators or making equivalent fractions. For example, if you had to add 1/2 plus 1/3, you would take 1/2 and multiply it by 1. This special 1 will be the denominator of the second fraction, which was 1/3. So it's going to be 1/2 times 3 over 3, and plus 1/3, and 1/3 will multiply by the denominator of your 1/2, which was 2, so that will be times 2 over 2. This you want to make a common denominator for both fractions. So you have a common denominator now, 3 over 6 plus 2 over 6, that equals 5 over 6. The other thing that we really need to know about is multiplying an expression by its conjugate. When you multiply an expression by its conjugate, you get a difference of square. The next expression is, or the final, or the resulting expression is a difference of squares. For example, x minus 2 is the conjugate of x plus 2. Notice the only difference between them is one has a minus sign and one has a plus sign in between. If you multiply these two, x minus 2 times x plus 2, you get x squared minus 4. X squared minus 4, x is a perfect square, x squared is a perfect square, and 4 is 2 times 2, so makes the perfect square. So that's a difference of square, difference of two square things. So that's x squared minus 4 is the final answer. This last expression, x squared minus 4, is what we call the difference of squared. Now let's look at a couple of examples. Simplify the expression, write the final form with no fractions. Secant squared x times cotan of x times cosine of x. Right? So we want to simplify this. The secant squared, we know that secant was 1 over cosine. Right? So this secant squared is going to be equal to 1 over cosine squared x. Secant squared x becomes 1 over cosine squared x. Cotan, we know from our identities, was cosine over sine. So it's going to be cosine x over sine of x. And cosine x is just cosine x. We're going to write that as cosine of x over 1. Now let us think of, can any of these things cancel out? Now if we have a cosine of x, we divide that into a cosine squared of x, we are left with a cosine of x. So this cosine of x, this is 1, and then this is cosine of x, the denominator. We have another cosine of x in our numerator. So there's another cosine of x in the denominator, so those cancel out. So what we are left with is 1 times 1 times 1. It's going to be equal to 1 in the top over 1 times sine of x times 1, so that's going to be sine of x. And 1 over sine of x, that was a reciprocal for cosecant of x. Cosecant CSC of x. And that is our final answer. So we have totally simplified this elaborate expression at the top to just cosecant of x. All right. So got another example. Simplify the expression, write the final form with no fractions. Simplify the expression, write the final form with no fractions. So here we have cosine of theta over 1 plus sine of theta plus tan of theta. Right. What we want to do is we want to use what we know about identifying identities first to simplify this expression a bit before we start applying the equivalent fractions ideas. So let's rewrite tan of theta as sine of theta over cosine of theta. So we end up with cosine of theta over 1 plus sine of theta plus tan theta is equal to sine theta over cosine theta. So that's our first step. The next step we want to do is that we want to use our equivalent fractions idea, right, to multiply. Okay, so multiply by the denominator from both sides. So then we have cosine of theta over 1 plus sine of theta. The denominator on this side was cosine of theta, so you multiply this by cosine of theta. It's a different color here. Multiply by cosine of theta over cosine of theta on the left side, and then we have sine of theta over cosine of theta. Then on this side, we multiply by the denominator of whatever was on the left side, so that's going to be a 1 plus sine of theta over 1 plus sine of theta. So we're multiplying. We multiply, we multiply straight across. So we're expanding this expression, right? And so now we have a common denominator and all of this, which is cosine of theta times 1 plus sine of theta, times 1 plus sine of theta. Okay, 1 plus sine of theta. Okay, let's distribute everything in the top part. We have that's cosine of theta times cosine of theta, which is going to be cosine squared theta. And this is going to be sine of theta times 1, so that's just going to be sine of theta. And then sine of theta times sine of theta is going to be sine squared theta. And so that is what is on the top. Now we know from a Pythagorean theorem that cosine squared theta plus sine squared theta is equal to 1. So then we can simplify the top part to become 1 plus sine of theta. And the bottom we have cosine theta times 1 plus sine of theta. And notice 1 plus sine theta is at the top, 1 plus sine theta is multiplied in the bottom, so that's just going to be 1 over 1. So your answer becomes 1 over cosine theta. And we know that's a reciprocal identity. It's a reciprocal for secant theta, so your final answer is secant theta. Okay. Simplifying expressions using common factors. We can simplify an expression by finding common factors of the numerator and denominator, which will eventually cancel out. In all cases, we'll be using factors from difference of squares. Remember that when we multiplied expressions which were conjugates of each other, we got an expression called the difference of squares. So if you factor a difference of squares, you will get the conjugates. Let's simplify this expression, tan squared theta minus 1, tan squared theta minus 1, tan squared theta minus 1 over tan theta sine theta plus sine theta. Okay, so here this is tan theta multiplied by sine theta, then plus another sine theta. Now, what we can do if we factor the difference of squares, you factor the difference of squares into its conjugates, We factor this difference of squares into its conjugate. Tan squared theta minus 1 will be tan theta minus 1 times tan theta plus 1. Right? And if we factor the denominator, if we factor sine theta from the denominator, we end up with tan theta plus 1 as the other factor. So notice there's common factor at the top and bottom, so these will cancel out, or say 1 over 1. So then we end up with tan squared theta minus 1 over sine of theta. So this becomes tan theta minus 1 over sine of theta. And then from that, we try to simplify. We know that tan theta is the same as sine theta over cosine theta. Make tan theta sine theta over cosine theta minus 1. Divide that by sine theta, and then invert sine theta over cos theta minus 1. You distribute this 1 minus sine theta into it, and we end up with 1 over cos theta minus 1 over sine theta. And so this simplifies to secant theta minus cosecant theta. And we are done. Thanks for watching. See you next lesson.